Alrighty, we know what a logarithm is, we know what common and natural log are, and so we can start looking at some logarithmic equations, and this is looking at simple logarithmic equations, alright? So let's add that caveat here. These are simple logarithmic equations, and just to remind ourselves, what is a logarithm? This is the key relationship here, that if you have a to the x power equals y, that is the same thing as saying log base a of y to be x. And so the logarithm is the inverse function of the exponential. It takes the variable out of the exponent. And so you have this windmill property here that log base a of y equals x, in the same way a to the x power equals y. All right, so you got to keep that windmill in mind. All right, now, without looking ahead to some of the properties of logarithms that we're going to learn, we're a little limited on the type of examples we can look at, but let's take a look at these. Okay, so here we have for part A, log base 5 of 2x equals negative 3. Here x is inside this logarithm. How do we solve this thing? Well, we don't really have a lot to go on right now. What we can do though is use our windmill to rewrite this logarithm as an exponential. Don't worry, it's not going to turn into an exponential equation, because watch what happens here. We're going to take our base raised to the negative 3 power equals this. So we end up with 5 to the negative 3 power equals 2x, which is actually a linear equation. So all the algebra we learned before exponential equations and logarithmic equations applies. Now I think 5 to the negative 3 power is the same as 1 over 5 cubed equals 2x. All right, and 5 cubed is 125, right? That's 5 times 5 times 5. And so then I get a value for x to be 1 over 2 times 125, which would be 1 over 250. Now, one thing you have to keep in mind with logarithmic equations is that you cannot have a negative in the logarithm. All right, so another way we could say that is the domain of a log is 0 to infinity. So what that means here is that I need to take this 1 over 250 and make sure that I don't get a negative in the logarithm. But if you multiply 1 over 250 times 2, you're not going to get a negative number. So this is indeed our solution. All right, I hope that makes sense. Let's look at a couple more, kind of following the same pattern, just for practice. Okay, now for B part, we have 4 raised to the log base 4x of 5 power. Okay, so the power is log base 4x of 5 equals 5. Now, this looks very complicated because, one, there's a logarithm in the exponent. There's also a variable in the base of that logarithm, so we're very limited. The only thing I know how to do here is to rewrite this using our whirlwind principle, right? This is a exponential, so if I say log base that of that, it will equal the exponent. Let me say that again. That's a log base 4 of 5 is going to equal the exponent, which is log base 4x of 5. Okay, now we got really lucky here because look, I have log base 4 of that equals log base 4x of that, and those two things are the same thing. It's 5 and 5, right? Which means that the logarithms are the same, which means that actually these bases, the two bases, have to be equal. So here we end up with 4 equals 4x because the bases match, right? They match. And so then I just end up with x equals 1. And there it is. Not too bad. All right, let me show you one more. Okay, so now I start out with log base 2 of 8 to the x power equals 5. All right, now we're going to do our whirlwind again. I think it's going to work. So here this time I'm starting with a logarithm. I'm trying to turn it into an exponential. So I know that's this base raised to that power equals this. So here I end up with 2 to the 5th power equals 8 to the x. Again, we're just using our windmill property. The base raised to the other side power equals what's inside the logarithm. So we get 2 to the 5th equals 8 to the x power. This is an exponential equation, and thankfully it's an exponential equation we can solve because it's common base. I can write 8 as 2 cubed, right? 2 times 2 times 2 is 8. So that's going to be 2 cubed raised to the x power equals 2 to the 5th. So since I have a common base, oh, and by the way, that 2 cubed to the x power is the same as 2 to the 3x. And so since I have a common base here of a 2, that allows me then to drop the exponents because the exponents have to be equivalent. And so I end up with 5 equals 3x, or x equals 5/3. And there is my answer. We can look at some more involved logarithmic equations, but first we need to look at some logarithmic properties, which I plan to do next. If you have any questions on this, please let me know. I'd be glad to help. And thank you for watching.